Precipitation reactions. We saw a couple of these types of reactions when we did the that copper cycle observation lab, and we had things changing colors. So in a precipitation reaction, we have two solutions being mixed together. Here we've got one clear solution, clear colorless solution, pouring it into another clear colorless solution, and bang, a solid forms. That solid that forms is called a precipitate. It's called a precipitate because it falls slowly through the solution, just like precipitation does. They're predicting rain today. The meteorologist says it's precipitation, right? Snow is precipitation. It falls. So this is the precipitate. Here's the equation, which I can't read on my screen. It's lead iodide and potassium nitrate. And we can predict which of those is the precipitate based on those rules of solubility. So let's look at how we would predict what the products are. We need to look at the original compounds. So we had potassium and iodide in solution. If we look at the rules, that's going to be aqueous. So we have potassium and iodide. And then we have lead-2 and nitrate. And that's a soluble ionic compound. So we've got lead-2 and we've got nitrate. So the possibilities here are that we're just going to swap ions. In order for a precipitate to form, it has to be an ionic compound composed of a cation and an anion. So we're going to look at the combination of potassium with nitrate and of lead with iodide, and then we're going to predict whether these are soluble or not. Potassium nitrate. Try to think through that table. Well, potassium is on that first row, right? Potassium compounds are soluble. So this can't be the precipitate. Oops. So that one's aqueous. And then lead iodide, okay, we went down, there was the potassium, lithium row, and then there was nitrate and acetate, and then below that were the halides, chloride, bromide, and iodide, generally soluble, except with silver, lead, and mercury. And so here we have the lead-2 with iodide, and so this is going to precipitate. It's going to form a solid. Okay, so I have this imaginary land I call Mrs. K's Chemistry World. I think it's a really fun place. Other people are not so thrilled with it, but I'm going to tell you about it anyway. And so this is how I see precipitation reactions in chemistry land. So here in this container, we have cations and anions. And I've told you before, I think of the metals, the cations, as being masculine, and the anions, or the nonmetals, as being feminine. And so here we have a guy and a girl, and they're going to a party together. They're just friends, but they're going together. And here is a guy and a girl, and they're going to the party together. They get to the party, and they're mingling around, and then lead sees iodide, and he's just blown away. She is just so amazing, right? And he just goes over to her, and she likes him too, and there's just like this instant chemistry between them, right? They form a solid. They're not mingling at the party anymore. They're stuck on each other. That's the couple on the back porch necking for the rest of the party, right? They're not talking or playing Trivial Pursuit or doing what everybody else is doing, okay? Because there's this strong attraction between them. How do you predict the attraction between two individuals? You can kind of predict, but you can't necessarily just say, oh, well, this person and that person, they're just going to hit it off instantly, right? And so, you know, just looking at different ions, you can't really predict it either, but that list of rules will tell us, oh yeah, lead and iodide, we should have seen that coming. They're going to go off together. Okay, so that's my analogy for precipitation reactions. So sometimes you go to a party and nobody is really attracted to anybody else, right? So here we have potassium iodide and sodium chloride. So we have potassium ion and iodide ion going to the party. We've got sodium ion and chloride ion going to the party. And then they get to the party and they mingle around and they're like, this is kind of fun, but there's no sparks, right? There's no chemistry. So there's not actually a chemical reaction that occurs. It's just a physical change. There was mixing. There was mixing that involved, but there's no changes. There's no new solid formed. And so the result of that is no reaction. Any questions? So for those of you who like steps, lists of instructions, here's your list. We need to be able to write precipitation equations, write equations for precipitation reactions, and this is how we're going to do it. You need to have the formulas for the two reactants, and then below that, write the formulas of the products that could form. So I'll show you an example, it'll become clear. Then look at the solubility rules to decide which of the possible products is a solid. Maybe they're both solids, or maybe they're both not solids. Maybe they're both soluble. If all the products are soluble, then you just write no reaction, you're done. That's always fine. If one or both of the products are insoluble, then you have to write the formulas. You have to indicate which one's a solid, which one's aqueous, and then you need to follow through and balance the equation. So let's put those into action. Write an equation for the precipitation reaction that occurs, if any, when ammonium chloride and iron 3 nitrate are mixed. First thing is we need the formulas for the reactants. And we're going to practice our nomenclature here. So, ammonium chloride. I'm going to write my equation up here, and below it, I'm going to write my ion formulas with their charges. So ammonium is NH4 plus because I memorized it. Chloride is Cl minus. Chloride's in group 7, 7A of the periodic table, and so all those guys have a -1 charge. So we can look at the charges on these, and that tells us how to put them together. NH4, Cl, I just need one of each. This question doesn't specifically say that these are solutions. So if I go to the list of solubility rules, ammonium is in the first row, always soluble, and so this would be aqueous. The next compound is iron 3 nitrate. So I need to write the formula for iron 3, that's Fe3 plus, and nitrate is NO3 -1. Just because that's what it is. And then I look at the two and their charges so that I know how to put them together. And I get Fe, NO3, 3. I need 3 of the nitrates to balance the charge on the iron 3. Is that compound soluble? Yes, it is. The first row, lithium, potassium, sodium, and ammonium. The second row, nitrate and acetate. This has nitrate in it. No exceptions. So this one's aqueous. So those are the reactants. Now I need to have these guys meet each other at the party and see if anything happens. So iron and chloride, I'm going to see how well they get along, and ammonium and nitrate. It has to be a positive ion and a negative ion, okay? Because these are electrostatic charges, right? This is where the analogy with real life breaks down, because you could have two guys going off on the back porch. It could happen. Pardon me? Yeah, it's going to be a metal and a nonmetal. You have to have a cation and an anion. The ammonium is the one you have to watch out for because it's not a metal, but it is a cation. So you have to have plus and minus. So we've got ammonium and nitrate, and I'm going to see how they work out together. So NH4 plus and NO3 minus, that's one possible combination. The other possible combination is the iron and the chloride. And we write the iron first because of convention. Like on a wedding invitation, it's Mr. and Mrs. It's always the cation first and then the anion. So before I bother to write formulas for these, I'm going to look at the solubility rules and decide if these are soluble or not. So what about ammonium and nitrate? Is that going to be soluble? Yeah. Ammonium compounds are always soluble. So that one's going to be aqueous. How about iron 3 and chloride? Chloride compounds are generally soluble. The exceptions are lead, silver, and mercury. This is not an exception. This one's also aqueous. So nothing happens. They mix, but no new compounds are formed, and so this is no reaction. Or sometimes we get really lazy and we just say NR, no reaction. Any questions? Just because you mix stuff together doesn't mean a chemical reaction occurs. Let's do another one. Write an equation for the precipitation reaction that occurs, if any, when sodium hydroxide and copper 2 bromide are mixed. Well, again, we need the formulas. So we'll start with the ions. Sodium is Na+. It's in group 1A. It's got +1 charge. Hydroxide, OH-, because that's what its name is. So putting those two together, I would get NaOH. The rules of solubility tell me that this is going to be soluble because all sodium compounds are soluble. Copper 2 bromide. Copper is Cu. The 2, Roman numeral 2, tells me the charge. And then I have bromide, it's Br-. And so this is going to be CuBr2. Is this one soluble? It was the third row, chloride, bromide, iodide, soluble except for lead, silver, and mercury. This one is soluble. There's my reactants. Now I have to swap partners and see what I get. So the copper and the hydroxide, the sodium and the bromide. It doesn't matter which compound you list first in the products, but within the compound you have to list the cation first. So I'm going to do Na+ with Br-, and then we're going to have Cu2+ with OH-. Compound between sodium and bromide, will that be soluble? Yeah, because sodium compounds are always soluble. So this one's going to be aqueous. How about copper with hydroxide? That's going to be insoluble. We go down to the bottom half of the chart. Hydroxide compounds are generally insoluble, except with calcium, strontium, and barium, they're slightly soluble. This is not an exception, so this is going to be a solid. Darn, now we have to finish this. Okay, so put them together, the sodium and the bromide, and that's aqueous. I'm writing this formula based on the relative charges. I've got 1 plus. Down here, this is not part of your answer, but this is part of showing your work. And I really think you should do this because otherwise you're going to make a lot of mistakes. I see it a lot. I wouldn't just write this out without writing stuff down until you get really good at it. So the copper 2 and the hydroxide, we're going to get CuOH2, and that's going to be a solid. Any questions? Are we done? No, we have to balance it. What's an ion that is not balanced? Excuse me. Sodium's balanced. The bromide isn't. So here we got Br2, 2 bromides, and here we only have 1. So we need to put a 2 here to balance the bromides. But that messed up sodium, right? Now we have 2 sodiums and only 1 over here. So I'll put 2 over here. And then I've got copper. There's 1 copper and 1 copper. I've got 2 OHs and, oh, cool, 2 OHs. Magic, yeah. So this part down here, I would encourage you to write that, but that's not part of the answer. Any questions?